Hello guys, welcome back to another video. I know the videos are coming very much late as I am mm, looking for jobs and stuff like that. That's why I can't upload frequently. But it is what it is. Sorry for being late though. I will try to do much better from now. Okay. So let's get to the problem. Today we are gonna do this rotate array problem. So the rotate array problem is this, right? So what does it says? We have given an integer array nums and a steps k, which is an integer, and we have to rotate the array till the steps k times. What does it mean? Let's go from here. So what does it says? Here it is given an array, right? 1, 2, 3, 4, 5. This is an array. We have to rotate it, let's say k equals to 1 time. So if we rotate the array 1 time, what will happen? We are gonna get this thing, right? Let's say one time rotation. After one time rotation, the 7 will be at the first, then this will be 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6. Means we are just taking the 7 from first to and putting it at the last, right? Putting it at the last. Same goes for if we do that for the second time. The 7 is at the front, but the 6 is at the last. We are going to take the 6 and put it into the front. Means what will be the uh, answer then for the second time rotation? It will be 6 5, sorry, 6 7, 6 7, then 1 2 3 4 5. Did you see what is going on? It is like every time we are rotating, uh, we are just putting the last element at the front, and this goes on for every time we are doing it. Now so this is the problem. Now how are we going to solve this problem? We have to think of brute force approach first. Let's think of how are we going to solve this problem. If we go for a brute force approach, which is like without thinking much deep into it, what we are going to do, we are, let's say, here we can see that we are taking the last element and putting it in the front, right? We are putting it in the front. So what we can do, we can just, let's say, create a variable, let's say int a, which will store the last element, right? Int a, which is store the last element for every step, right? For every step, we are going to store the last element over here. And we are seeing that every two elements are like changing. Like one goes from here to here, two goes from here to here, three goes from here to here. Only the last element comes at the front. So what we can do is we can just, let's say, store the last element, right? Store the last element, and then we can just replace the this with the previous element. Replace this with the previous element. So what is the meaning of that? Um, let's say for this one, right? Let's say for this one, let's do 1, 2, 3, 4, 5, 6, 7. For this one, if we do nums of n, let's say nums is the array I equals to nums of I minus 1, then what will happen? It means that nums of I, let's say nums of I is here, is equals to nums of I minus 1, means 1. Means what will happen is we are gonna replace this 2 with the 1, right? And we are gonna start the loop from the last element, let's say last element. So what will happen? Let's say I over here, this is I, right? This is I will just replace with the 6, means the 6 will be at the front. The 6 will be at the front first, then there will be 5, there will be 4, there will be 4, right? There will be 3. This way we are gonna go. So what will happen, what I am saying is we are gonna run a loop from let's say I equals to n minus 1 to let's say 0, or let's say 1, uh, and we are gonna replace the I minus 1 element with the I element, or replace the I element with the I minus 1. And at the end of the loop, outside the loop, what we are going to do is nums of 0, we'll store it in the last element we get to store in the nums of 0. What is the meaning of that? We are going to store the, let's say, we are going to store this 7 into the front, the last element we get to nums of 0. And then we are going to just replace 7 with the 6, 6 with the 5, 5 with the 4, 4 with the 3, 3 with the 2, and 2 with the 1, right? So this way we can brute force this thing, right? Nums of 0, and this will be the variable we have chosen is a. This will be a. So this is the outer loop. Okay, this is the outer loop. But there, this is the inner loop. There will be another loop which will count the steps. What will be the steps? Let's run a loop from I equals to 0 to, let's say, k. Means k step we have to take. Means we have to reverse the whole array k times. Right? We have to reverse the whole array k times. And so we have to reverse the whole array k times, and then after that we will gonna store the last element of the array into the like variable. Let's go on nums of last means n minus 1th element into an array. So this is the whole brute force approach. Okay, let me just clear this thing. Okay, so this is the brute force approach. We are gonna run a loop from 0 to k, means k steps, and then we are gonna store the last variable into last element into a variable. Then we are gonna come from last to the towards the first, last towards the first, and replace all the previous element with the current element, previous element with the current element, previous element with the current element. This is the whole brute force approach. Now, what is the complexity of this brute force approach? Okay, what is the complexity of this brute force approach? Let's do time complexity of this approach should be. Now, here is the thing. You can just say there is two loops, so you can just say there it will be O of, let's say, n square, right? Because there is two loops. But no, the first loop runs till k, and the second loop runs through the whole array. So it is not a O of n square, more of like k into n or n into k times, right? This is the whole time complexity for the brute force approach. So this is the brute force approach. We can go for with this, or as it is not a good time complexity, we have to change this approach into some better approach. So this is the main approach, or this is the more optimized approach, you can say. What we're gonna do in this optimized approach, we are gonna take this array, this whole array, we are gonna reverse the full array. Means we are gonna reverse till 0 to n minus 1, fully reverse the array, right? We are gonna fully reverse this array. Now after that, what will happen when we are gonna fully reverse this array? This will happen. This thing will, the array will become like that, right? As fully reverse, after the fully reversing the array, what we are gonna do? We are gonna reverse the array till the k minus 1 elements. Means what? Here k is, let's say, 3, right? K minus 1 means 2 elements, means 0, 1, 2. We are gonna reverse till this much, and this reversal will cause to this, means 765 will become 567. Means the next steps will be reverse till, let's say, 0 to k minus 1, right? 0 to k minus 1. After that, what we are going to do, means after this, the array will become this. Now, next portion, what we are going to do? We are going to reverse the, means the left out portion, which is this 4, 3, 2, 1. You can see this is the left out portion. If we reverse the left out portion, it will become like this 1, 2, 3, 4. The whole thing will get reversed. Means what is the next step that will cause this? We are going to reverse till 0 to, let's say, not 0. We have to reverse from k to n minus 1, because it is starting from k. We have reversed till k minus 1 in the second step, and in the third step we have reversed the left out portion, Relocated whole thing. What happens? We first reverse the full array, then we reverse the array till the k minus 1, then we reverse the remaining portion, reverse the full array, then we reverse the k minus 1, and then we reverse the n minus 1. But there is a edge case also. What is the edge case? Let's say the k is greater than n. Means what? The size of the array here 1, 2, 3, 4, 5, 6, 7. Let's say 7 is the size of the array. So the size of the array and the rotation, how much we have to rotate, let's say over here 3. But if it is not 3, if it is like 8, if it is like 9, what will happen? Then it will not gonna work, right? That's when we are gonna do a edge case where we are gonna, let's say, k modulo n. What does modulo do? Modulo gonna return the let's say remainder. Means 7 is the size of the array and we are gonna divide it by 3. Here k is 3. So it will gonna return, let's say, check if the k is greater than or not. If it is, it will gonna divide it by that and return the amount, and it will just gonna run till the k. This is the edge case solution. Okay, so this is the code. What is happening over here? We have taken the size k equals k modulo equals to n. It is the same as like k equals to k in modulo n. Then there is this thing, reverse till the like 0 to n minus 1. Then we have reverse k minus 1. Then we have reverse k to n minus 1. Over here, what we do, we have taken start element and the end element and the nums array. We have interchanges between the start and end, right? Start and end. So what does start and end interchange means? Let's say this is the start element and this is the end element. We have taken this and let's 3 will be over here, 1 will be over here. Same for here. This is the start element, this is the end element. Then 7 will go over here, 4 will go over here. Then start will be over here. Means let's say end will minus minus, start will get plus plus. Then 6 will be over here and the 5 will be over here. Okay, so this is happening over here and let's run this code. Yeah, it runs and yep, test case. And the time complexity for this problem is this solution is O of n. Okay, the time complexity was O of n and we didn't take any extra spaces. That's why the space complexity is O of 1. And that's the problem. Okay, guys, thank you for watching the video. If you guys understood it, let's say, comment, like, whatever you want to do. Thank you.